Hello everyone, welcome to chapter 2, lesson 4. In this lesson we are going to work on solving equations that contain fractions. I am going to focus in this lesson on showing you how to eliminate fractions when you have them, because if you're anything like me and most people, you don't enjoy working with fractions. They're not the easiest of mathematical things to solve and work with. So one of the strategies that we do teach is how to just eliminate them altogether. The terms that you do need to know for this section are least common denominator, which we refer to as LCD, no solution, and infinite number of solutions. So when equations involve fractions, the easiest way to solve the equation is to first clear out the fraction altogether. And what that means that we're going to do is completely eliminate the fraction by multiplying the LCD of the fractions through the entire equation using the distributive property to create whole numbers instead of fractions. Now, keep in mind that we are allowed to do this because an equation is like a scale, okay? And as long as we perform the same operation to both sides of the equal sign to every term in our equation, that equation is going to remain balanced. Okay? So as you're thinking about this section and you're thinking, how is it that we're even allowed to do something like this? That's why. Okay, as long as we do the same thing to both sides of our equation all the time, our equation is going to be balanced and we can manipulate it however we want to. Now, let's take a look at some examples so that we can start to learn how to eliminate fractions. Now, when you first look at example A, we have three different fractions. We have 1/4, negative 2/3, 5/12. When you look at that equation, it's ugly. Okay, there's no way around it other than to say that it's an ugly equation because it contains all of those fractions. It has variables on both sides of the equal sign. If you wanted to work with it in fractional form, you would have to get common denominators, change your fractions, do all of that stuff in order to just simply combine your variables and solve. What we're going to do is eliminate the fractions by using the LCD of the fractions. LCD stands for lowest common denominator or least common denominator, however you were taught the vocabulary word. I've heard it both ways. And the least common denominator is the smallest number that all of your denominators will divide into. So as we're looking at 4, 3, and 12, the smallest number that every single one of those will divide into is 12. So that means that the LCD of letter A is 12. Once you identify your LCD, what you're going to do at that point is multiply your entire equation by your LCD using the distributive property. So I'm going to draw parentheses around my entire equation, the whole thing, and I'm going to draw my LCD in front because what we're going to be doing is distributing that 12 in. Now, you can approach this two different ways. It depends on what's easier for you, and I want to show you both ways for this step. Okay? Now, the way that I do it as I'm distributing is I say 12 divided by 4 is going to leave me with what? Because I'm going to allow that 12 and that 4 to cross cancel. Okay? So 12 divided by 4 leaves me with 3. 3 times 1 is 3. So that leaves me with a 3x. Repeat the process for your next term. 12 divided by 3 leaves us with 4. 4 times negative 2 is negative 8. Okay, you cross cancel first. So 12 divided by 3 is 4. 4 times negative 2 is negative 8. Bring down your equal sign. Last term, we're allowing it to cross cancel. 12 divided by 12 is 1. 1 times 5 is 5x. Okay? At this point, you have completely eliminated every single fraction by cross-canceling and multiplying. Now, some people find it very hard to use the cross-canceling method. So what they choose to do is straight multiply that 12 in, and after they take care of that straight multiplication, they'll divide. So what I mean by that is that we'll do, think of these like a 12 over 1. So you'll do 12 times 1 is 12, 1 times 4 is 4x. And then we're going to go to the 2/3. 12 times negative 2 is negative 24. 1 times 3 is 3. And then we will multiply to the 5. 12 times 5 is 60. 1 times 12 is 12. And then that's an x term, so that's x. Then you can divide. 12 divided by 4 is 3x. And then we're going to move on to the next term. Negative 24 divided by 3 is negative 8. And then the last term, 60 divided by 12 is 5, and that's a 5x. So as you can see, we have the same next line regardless of which method you used. It depends on what you're more comfortable with. If you are able to cross cancel and multiply in the same step, go for it. If it's easier for you to straight multiply and divide to get that next equation, do it that way. Okay? Regardless, we have the same equation, and then from there, whichever method you chose, we're going to go ahead and simplify the equation from there. Now you need to get your variables on the same side of the equation, and I'm going to go ahead and write on this side. Okay, I want to move my positive 3x over to the other side, so I will move it using subtraction. So I'm going to minus 2x on both sides. Excuse me, I'm going to minus 3x, not 2x. 3x, because I want to cancel out that 3. So I have negative 8 equals 2x. And then we're going to divide both sides by 2. And negative 4 equals x. And there's our answer there. So we took an equation that looked really ugly, and all we did was eliminate those fractions using that LCD. So let's take a look at letter B. We're going to do exactly the same thing. I'll walk you through both steps, both ways of canceling it out so that you can see which way you like better. Okay? The LCD, as you're looking at 15, 3, and 5, we want the smallest number that all of those denominators will divide into. So the LCD here will be 15. So we're going to put parentheses around the entire equation and put the 15 in the front. We now want to distribute that 15 into every single term in that equation. So you have a choice. You can cross cancel and multiply, or you can straight multiply and then divide. It's up to you, and it depends on which method you liked better. So let's do the cross canceling and multiplication first. If we cross cancel first, 15 divided by 15 makes 1. 1 times 1 makes 1. So that leaves us with 1x. 15 divided by 3 makes 5. 5 times negative 2 makes negative 10. 15 divided by 5 makes 3. 3 times 4 makes 12x. So all of the fractions at this point are gone, and we used the cross-canceling method to eliminate them. Now let me show you if you wanted to use the straight multiplying method. Okay, remember that's a 15 over 1. So we're going to straight multiply. 15 times 1 makes 15. 1 times 15 makes 15. And that's an x term. Now we're going to multiply 15 to the 2/3. So 15 times negative 2 is negative 30. 1 times 3 is 3. And then we're going to multiply 15 to 4/5. And 15 times 4 makes 60. 1 times 5 makes 5, and that's an x term. And then you just simply reduce your fractions. 15 over 15 makes 1x. Negative 30 over 3 makes negative 10. 60 divided by 5 makes 12x. So we have the exact same equation both ways. It just depends on you and your preference as to which way you want to use to simplify those fractions and clear them out. Okay? So now let's go ahead and solve the equation. We do want to get our variables on the same side, so we will begin by moving the x. It is a positive x. Please remember that the sign in front of the number is the one that you need to focus on. So we're going to subtract x from both sides. Negative 10 equals 11x. We will divide both sides by 11. And we have negative 10 11ths equals x. And that is our answer. I would like for you to go ahead and try examples C and D. Pause the recording. Whenever you're ready, we'll go ahead and check our work together. Okay, at this point, everybody should have had an opportunity to solve problems C and D. In letter C, you needed to first start by identifying the LCD between 3, 5, and 3. The LCD here is 15. So we will be distributing a 15 through our entire equation. 15 divided by 3 leaves us with a 5. 5 times x is 5x. For the second part of this, there is no fraction, so that is just multiplication. 15 times 3 is 45. 15 divided by 5 is 3. 3 times x is 3x. 15 divided by 3 is 5. 5 times 1 is 5. Now we have an equation with all whole numbers or integers, and we have variables on both sides, so we need to move one to the other side. I will subtract 3x from both sides. 5x minus 3x is 2x, plus 45 equals negative 5. Next, we want to subtract 40 from both sides. 2x equals negative 45. No, let me back up here. We're going to subtract 45 from both sides. 2x will equal negative 50 when we add. And then we will divide both sides by 2, and x equals negative 25. For letter D, your LCD here is 4. So we're going to put parentheses around everything, and we will be distributing in a 4. 4 divided by 4 is 1, so that leaves us with an x. 4 divided by 2 is 2. 2 times 1 is 2. This term is not fractional, so we will just distribute and get 4x. 4 divided by 4 is 1, times negative 7 is negative 7. We need to get our variables on the same side, so we will subtract x. 2 equals 3x minus 7. We will add 7 to both sides. 9 equals 3x. Divide both sides by 3. X equals positive 3. Now our next set of examples is just slightly different, and the reason that this next set of examples is slightly different is because either our numerator or our denominator is going to contain a group. Now don't worry about that. You're still going to solve the problem exactly the same way. We're going to identify an LCD, and we're going to distribute that LCD through the equation exactly as we have done in the other ones. Okay, as we look at letter E, we will notice that the LCD here is 8. The smallest number that all of the numbers will divide into is 8. So we're going to multiply an 8 through every term in the equation. So as we allow the cross canceling to happen, 8 divided by 8 makes 1. That leaves us with x plus 2 in the numerator. Bring down your equal sign. Cross cancel on to the next term. 8 divided by 4 is 2. 2 times x is 2x. Lastly, 8 divided by 2 is 4. 4 times 1 is 4. So the equation started out looking nasty, but once you do that elimination with the LCD, we're down to just a normal equation that we have been working with. We're going to subtract x from both sides, and that leaves us with 2 equals x plus 4. Next, we will subtract 4 from both sides, and that leaves us with negative 2 equals x. Letter F is very similar. I would like you to pause the recording, solve the problem, and when you're ready, we will move forward together and check our work. Okay, by now everyone should have had an opportunity to solve letter F, and we should have found that our LCD for letter F is 15. So we will be distributing a 15 into the entire equation. 15 divided by 15 is 1, so that means that we will have 5x plus 12 left in the numerator. 15 divided by 3 is 5. 5 times 1 is 5. So we'll bring down a positive 5. 15 divided by 5 is 3. 3 times negative 1 is negative 3. We can combine like terms before we move forward. 12 plus 5 is 17, so we will combine those, bring everything else down. We must subtract 17 from both sides. 5x equals negative 20. Lastly, we will divide both sides by 5, and x equals negative 4. Now we have one last set of examples that we need to go over. And as you will see in this set of examples, we have a fraction in front of a quantity. So for this one, we will still find the LCD, which is going to be 15 because we have a 3 and a 5. However, you have to be very careful about how you do your distributing here, because the term 1/3 times quantity x minus 2, this is considered to be one term. So when we distribute to it, we are only going to multiply to that term one time because it is just one term. Similarly, this is considered to be one term because it is multiplication. Remember that we said that terms are separated by addition and subtraction. In our original equation, we just had 3 terms. We had the term on the left and 2 terms on the right there. So we're going to multiply to fit by 15 here, and then we will multiply our positive 2 by 15. Okay, we will not distribute that 15 into those quantities. Now we're going to allow the 15 and the 1/3 to cancel, so 15 divided by 3 is 5. 5 times 1 is 5. Bring down your quantity. 15 divided by 5 is 3. 3 times 1 is 3. Bring down your quantity. And then 15 times 2 is 30. Now that you have allowed or eliminated your fractions by allowing them to cross cancel with your LCD, you can now distribute that whole number into the quantity rather than trying to distribute a fraction into the quantity. So we will do 5 times x is 5x minus 10 equals 3x plus 12 plus 30. We can combine like terms on the right hand side because 12 plus 30 is 42. We will subtract 3x from both sides so that our variables are on the same side of the equation. 5x minus 3x is 2x. We will bring everything else down. To undo subtraction, we must add, so we will add 10 to both sides. So 2x equals 52. Lastly, we will divide by 2, so x equals 26. Letter H is very similar. We're starting out with just 3 terms because our fraction is being multiplied to a quantity. So you want to identify your LCD and then simply multiply that LCD to each term to start out with. Our LCD here is 4. So we're going to multiply 4 to that term, 4 to this term, and then 4 to that term. So 4 divided by 2 is 2. 2 times 1 is 2. Bring down your quantity. 4 divided by 4 is 1. That's just going to leave us with a 3x when those cancel. 4 divided by 2 is 2. That 2 times 1 is 2. And then bring down your quantity. So now instead of distributing fractions into your quantity, you will be distributing whole numbers. 2 times 2x is 4x. 2 times 27 is 54. Bring down your 3x. 2 times x is 2x. 2 times 3 is 6. Check to see if you can combine like terms. We can. 3x plus 4x makes 7x minus 54 equals 2x plus 6. We will subtract 2x from both sides. So that gives us 5x minus 54 equals 6. To undo subtraction, we will add 54 to both sides. 5x equals 60. Divide both sides by 5. And x equals 12. Now please keep in mind that it is not mandatory to eliminate fractions, but we do teach the strategy of eliminating fractions because it makes equation solving easier. Without this strategy, you would have a lot of fractions and a ton of mathematical manipulation in your equations, and it makes the equation solving significantly harder. So if you can master this concept of eliminating fractions, it will make your work much easier in the future. The last thing that I have in here is just general steps for you on how to solve equations. So this is just a refresher for us. It's just a general statement, not anything in particular with adding or eliminating fractions, but just rather I wanted to give this to you so that you had this strategy. So we're going to start by removing parentheses. If there's fractions, you want to multiply all terms on both sides by the LCD to clear them. Combine like terms. Add or subtract on both sides of the equation to get all of the terms on both sides, or on one side I should say. Add or subtract your constants. Divide both sides by the coefficient to clear out your multiplication, and simplify. So this is just a nice little checklist for you that organizes the rules for equation solving for everything that I've taught you so far in chapter 2. And then this last little thing here is just a little to think about section. And I want you to know, it says, does every equation have one solution? And the answer here is no. And this little section is actually very important because sometimes as you're solving equations, you are going to come across a situation where sometimes your variables cancel out. For example, let me rewrite this little problem over here. We have 5x plus 15 equals 5x minus 8. As you're looking at this problem, your first thought is, well, I need to get my variables on both sides. So you start to subtract 5x from both sides. But the 5x's cancel, and we're left with 15 equals negative 8. It should be obvious to us that that's not a true mathematical statement because 15 does not equal negative 8. When this situation arises, the answer to your equation is no solution. You can either write the words no solution, or you can use the no solution symbol, which is a circle with a slash through it. Another situation that you may come across is one such as this, where when you have an equation that has x minus 7 equals x minus 7, you might try to subtract your x's from both sides, and then we get a true mathematical equation that says negative 7 equals negative 7. That is a true statement. So the answer to this equation, since there is no x left, is that the equation has an infinite number of solutions, and you would write those words as the answer. So we can solve our equations and get one solution where we have x equals a number, but if our x's cancel out completely, our equation will either have no solution if your result is false, or infinitely many solutions if your result is true. The no solution result means that there is absolutely no number that exists that will make your solution or your equation true. Infinite number of solutions means that every number in the world will make your equation true. If you have any questions about what we did in this lesson, please feel free to let me know. Contact me and I'll be more than happy to work with you. Thank you.